So given that they know now about the capacitance and the photoelectric effect, there are a few other things. Quantum efficiency, for example. Quantum efficiency, okay. So not all the photons incident on the capacitor's surface will be able to eject electrons, okay. So for example, 3 photons could only eject 2 photons. That would indicate a quantum efficiency of 66%, okay. So normally this quantum efficiency ranges between 70 to 80% in CCDs, okay. Magnification. So let's say there was an image or there was an object here, okay, and it was captured by the shutter of a camera, and the image was produced on a CCD, okay. So the image over here, this is the image. So the magnification is defined as the length of the image divided by the length of the object. Notice that I'm talking about the length, not the area, because in some exam questions you are given the area, and then given the area you must convert that into one dimension and check the length of the image divided by the length of the object, okay. So that's the definition of magnification. Resolution is simply the number of capacitors. So usually you would have millions of capacitors on one CCD. So the number of capacitors is called the resolution. For example, you might have 1800 columns of capacitors and 1600 rows, okay. So then the resolution would be 1800 times 1600, okay, which might turn out to be 2.88 million capacitors. Now each capacitor here is called a pixel, okay. The pixel is the smallest quantity of is the smallest entity which can hold one value of voltage information relating to one value of the intensity incident on it, okay. So this would be 2.88 million pixels or 2.88 megapixels. So that's resolution. Okay. Now, in order for 2 points, okay, let's say we have 2 objects here, and the image over here is placed on the CCD, okay. Now, in order for these 2 points to be resolved, the length, the separation of the image, right, these two should be at least 2 pixels apart, because if these 2 images are on the same pixel, okay, let's say this is a pixel, okay, so if they are both on the same pixel, then the information stored in the pixel would only be one value, and therefore there would be no resolution. We would not be able to resolve between these 2 information separately. So in order for the 2 images to be resolved, we must have the distance between them be at least 2 pixels. Okay? Therefore, this means that the length of the image must be greater than at least 2 pixel widths in order for it to be resolved. So you can see this at the top of page 8, that in order for us to resolve an image or the image of 2 objects, the length of the image should be at least 2 pixels. We've discussed quantum efficiency, magnification, resolution, and also the minimum criteria for resolving 2 objects on a CCD. Now, after this, the student should be able to use this information. For example, they might be given the dimensions of a CCD, and using the dimensions of the CCD and number of pixels, they should be able to figure out the dimensions of a pixel. each pixel is usually a square pixel, so it should be easy for them to find out the length of each pixel. Now, a range of practical uses of CCDs is any application which needs to capture light information. For example, DSLR cameras or scanners, scanners, Xerox machines, photocopiers, and then 14.2.10 is describing the process in which an image is stored in a CCD and is retrieved. So that's the process that we just went through. 14.2.11 is just using all of these concepts in numericals. So going through examples 1 and 2 should actually use all the concepts that we've learned over here. Now remember, just one note, I believe the final answers to examples 1 and 2 need correction over here. So you might want to work it out step by step with the students and also discuss this. So that pretty much ends our chapter 14, and that covers the core section of the syllabus.